Hello.
Hello.
Hi, Demetrius. Uh,
Hi.
can you hear me?
Yes, absolutely. Yes. Right. I also ping William.
Reminder. Thank you for the reminder. Okay, so I'll introduce the speakers first. We have William Lindskog-Münzing, who is a solutions engineer at Flower Labs, and he has industry experience in the heavy asset industries. His research experience at TU Munich includes federated learning for tabular data and machine learning application in the automotive industry. He has also recently led the research and development team at TUM.ai, which is Germany's leading student AI lab. William also contributed with FedPer baseline during Flower's 2023 Summer of Reproducibility initiative. Co-leading this workshop is William's colleague, that is Dimitris Tripelis, who is a research engineer also at Flower Labs with industry experience at Amazon Web Services, as well as Salesforce. He earned his PhD from the University of Southern California and worked as a postdoc researcher at USC's Information Sciences Institute. He is a recipient of the USC Marinus Fellowship and the A.G. Leventis Foundational Educational Grant. His research focuses on federated and distributed machine learning. He has served as a reviewer for many conferences, including NeurIPS, ICML, AI Stats, AAAI, EMNLP, ECAI, and WISE, as well as journals such as TNNS, TMI, and TKDE. He co-organized the first Federated Learning Systems FLSys workshop at MLSys 2023 and the Federated Learning on the Edge FLEDGE symposium at AAAI 2024. Guys, thank you so much for your time, and the floor is all yours. We look forward to your presentation.
Thank you very much. So my name is William. Happy to be here. Hope that everyone is having a good day, good morning. First of all, I'll also just give the word to Dimitris. He can also say hi to everyone.
Hello, everyone. Good morning. Hope you have a great day as well, and we're really happy to be here and kick off the day 3.
Perfect. Let me share my screen. I think this is full screen right now, right?
Yes, we can see you.
Perfect. Okay. Yes. So welcome everyone. We're really excited to be here and talk about what we do at Flower today. We'll focus on the topic of scaling federated AI from research to production or research to like large scale deployment. But hope that you're excited for this. We will have some small breaks when we allow for questions and so Q&A, and also a break in about like a short break, maybe in 45 to 50 minutes. So I will start to talk, and then Dimitris will come in later and show some other things. But yes, before I go into what we will talk about today, I just want to show you the QR codes here. This is where you can find on the left side, that's where you find all of our code on GitHub. This is the open source code that you can use to create your own federated systems. And then on the right, you have an invite to our Slack channel. This is where you can always 24/7 chat with us. We try to be as available as possible. So if you have questions, if you have ideas for projects or anything that you would like to discuss with us, this is the easiest way to get in touch with us. We are also on socials, but Slack is the go-to channel where we operate. The agenda is I'll talk about why and how we work with federated AI, then go into the Flower framework, some basic introduction to it, examples, and about Flower in deployment as well. Then we'll do a short break and allow Dimitris to come in later and show a Flower demo, some stuff, and then also talk a bit about Flower Intelligence. So I hope that you're excited, and sit back, relax, and try to enjoy the presentation. starting with federated AI. Why do we work with it? Well, we believe that we are unlocking the next AI era or breakthrough. If you look back over the last 10 to 15 years, you see that the recipe for getting to a better AI has been scale. We saw the models, the early models in around 2010, they were a couple of millions of parameters, and they are now in the terms of trillions. And of course, their capabilities have exceeded most of our expectations. This comes together with the scaling of compute. So first, you were able to run the models quite locally on a couple of GPUs, and now you see these announcements about the hyper clusters of hundreds of thousands of GPUs bundled together in order to power inference, training, pre-training, post-training, fine-tuning, everything like this for the state-of-the-art model. So what has happened on the data front? Well, we started out with some ImageNet, some MNIST data sets, and things like that, and they have also scaled, but we've reached kind of the limit of what is possible to extract from open sources, at least if you look at AI in a centralized and traditional way. These numbers should be taken with a pinch of salt, but right now, in order to power and train the state-of-the-art language models, we are scraping the whole web, basically. And this is approximately 15 trillion tokens. So right now, the state-of-the-art models out there are basically training on the whole web, everything that is available out there for the public. Nevertheless, we think that there's a massive untapped potential. And this untapped potential is the data that is locked behind organizational kind of borders and walls, also quality data that reside in silos that are not necessarily accessible to the public to begin with. And this rough number here is estimated to be about 2,000 trillion tokens. So just to put it in perspective, this is the smaller one is the data that we're currently training the state-of-the-art model on. And this is the unused, untapped potential. So this bigger circle is what we could train and what if we already have these capabilities that we are quite fascinated by today, you can just imagine what they could be like if we can tap into this potential, this larger sort of group of data. Just to put it in perspective, this is around somewhere between maybe 125 to 150 times larger than what we are currently training on. So yes, there's a massive potential here, basically. Now, how do we work with federated AI? We just went through why, so how do we work with it? Well, in a centralized AI kind of workflow, you have data being sent from different silos, organizations. I like to think of it in healthcare, for example, where you have hospitals sending data to maybe a central storage, could be patient records, blood values, whatever it is, that's being sent to a central storage. And that's sort of the traditional way of running AI. And then at the central storage, you do fine-tuning, you do pre-training, inference, whatever it is. So yeah, and you can think of it for any other sort of use case. You can take finance, that's also, you have credit data, automotive is one. So just try to imagine maybe one of your favorite use cases done in a centralized way, and then flip it upside down. So what we do with federated AI is that we want to train the AI models locally and never send the data. So the data reside where it originates, basically. And how we make this possible is through, if you imagine machine learning model being sent out to the different silos, let's take hospitals, for example, you send them out as copies. They train locally on the data that they retrieve from there, and then send back the model weights and biases. So the internal parameters, they send them back to some could be some sort of aggregator, and then they aggregate all these updates and form a new, better model and send those out. So the data never leaves, you just send model weights and biases back and forth. And this is what we do at Flower, so at Flower Labs. So the Flower framework is our tool to work with this. It's a production grade system for federated learning, analytics, and evaluation. And you can use it. It's open source to begin with. So you can go there, find examples, you can read how to work with it. And if you want to go to our website, you'll find more information. So that's flower.ai. And we try to make it as intuitive as possible to spin up examples and work with federated AI. So as of now, today, you basically, when you go to, I don't know, your VS Code or wherever you work in, you would do pip install Flower, and you have that installed then. And in order to run a template, just to see how federated learning works, we have a simulation engine which allows you to see this locally on your computer, on your CPU or GPU. You can run Flower new, and it will ask you for what template do you want to use. Let's say PyTorch, TensorFlow, scikit-learn, whatever. And you'll choose, let's say PyTorch. You get a template, and this includes the scripts that run on the server, sort of the aggregator, and then second, also the ones that run locally on the hospital, so on the device or whatever you're using it for. So you get those scripts, and then you run Flower run, and then it basically runs the whole federation. So 2 commands after you've installed it, and you can see how it actually works on your own computer. And then this is simulation engine, and of course you can take it to deployment later on. But what I also want to say is that we try to make it as modular as possible. So plug and play, you can use it for different sort of data modalities, text, image, tabular data. You can add security mechanisms on top of it, such as differential privacy, encryption techniques, secure aggregation, and some other sort of more sophisticated strategies. And yes, we also make it possible to deploy it in, let's say, real world production systems or just global federations. And you can manage it through state-of-the-art Kubernetes clusters as well. So we try to achieve the best health of the different sort of images out there and also the clusters. So we try to maintain a really good and A+ score for this basically. So what I want to say with this is that we are heavily invested in the infrastructure, just making sure that it is of the highest quality so that you can deploy it in production grade systems as well. And we're very proud of our community. If you go to our GitHub, you'll see that a lot of people star our repository. And in our Slack channels, we are closing in on 7,000 developers that are actively asking questions and communicating with us. We're very proud of the 2,500 dependent projects that we know of that are open source, and we know that they exist and build on Flower. They are used for both enterprise and academic purposes. We try to, of course, if anyone reaches out to us, then we try to help them if there's anything they are looking into. And if you want to, you can also become one of the active contributors to our framework. So you can go to our GitHub. Maybe if you want a feature request or something like that, you can open a pull request and implement it yourself. We will review it. And if it's, successfully merged together with our syntax and documentation, you'll be an active contributor to the Flower framework as well. Yeah, and we organize events all throughout the year. We just had one, a big one in San Francisco back in September. We have our Flower AI Summit. It's yearly. It's in London. And then we try to organize some smaller stuff every now and then. So, check out flower.ai if you're interested in joining one of these events, or reach out to Dimitris or I. As of late, we've focused on large weight support, so making sure that you can fine-tune, train, and run inference for very large language models. So you can federate any model, any size, and with zero code changes. This is available since one of the recent versions. I think we're right now at 1.22. But yeah, this is if you want to run bigger models in a federated setting, you can do that now. We do that by kind of chunking the messages that are being sent back and forth, and this gives us savings on the bandwidth and also wall clock reduction. Here is one of the examples where we trained a Qwen 3 8 billion DeepSeek model. So these are just some of the numbers, and this was trained in sort of a federated way across Europe. This is just one example, but we also have a bigger leaderboard that I will show later on how to do this. But if you're interested in this, feel free to talk to us afterwards or ask questions, because a lot of people show interest in this at this point. I just want to highlight some Flower users that we work with. So we work across different verticals in the consumer space, also in industry, a lot with academia. Our manager is Professor Nick Lane at University of Cambridge in the UK. So we work closely with his chair, but also other universities, and we try to make sure that we stay active and support research projects as well, both in industry and academia, basically. One of the recent initiatives was led by one of our colleagues, Jan, who started FlowerTune LLM and its leaderboard. So what FlowerTune allows you to do is to fine-tune a large language model. We saw that earlier, but a large language model on various tracks and in a federated way. So instead of fine-tuning it in a central storage or a central server, you can fine-tune it across various compute resources. And right now we have a leaderboard which shows if you want to fine-tune these sort of models on different tracks, you can do that. You can use it for general natural language processing, finance, medical, and for coding tasks as well. So the idea with this is that, okay, let's say you want to see how this LLM works in a federated setting. You can fine-tune it across various nodes, test it out on real benchmark data. So you can see, and you choose a track. So let's say you want to do finance, you can test it on a kind of acknowledged finance data set, and then you submit the evaluation and the results. And this includes both communication cost, model performance, such as accuracy and things like that. And you can go to our website and see where models rank as of now in these 4 different tracks. And a lot of people reach out to us and say that they've chosen this model based on the leaderboard right now. So if this is something that you're interested in, doing a side project, testing out, you can feel free to submit your results there as well. Dimitris actually created this example. FedRAG is Federated Retrieval Augmented Generation. And what it does is that it retrieves and merges context from documents belonging to decentralized data silos in order to answer RAG queries. So this is something that we saw a lot of people asking about. Okay, how do I do RAG in a federated setting? We now have an example, so you can go to our GitHub and check this out. You can use it already if you would like to. I just thought I would highlight it here as well, as maybe someone is interested in it. And another thing is that we have a deeplearning.ai course out there for anyone who's interested in learning more about federated learning. So it's actually 2 courses right now. You'll see 2 of our co-founders here. They implemented this course, or they developed this course for Introduction to Federated Learning or Federated AI, and also how to fine-tune large language models with Flower, basically. So this is up on Deep Learning AI since of last year. So if you're interested, feel free to go there and check it out. It's free. So yeah, that's my first breakpoint are there any questions at this point?
I don't see any questions in the chat either. I think we can proceed.
Okay, great. Let me just yeah, and if there is, you can also wait to the next one. We'll do a break in maybe 20 minutes or so. Yes, so we talked about kind of why and how we work with Federated AI, also a bit of introduction to Flower itself. Now, I want to talk about Flower in deployment. If you were to break down the Flower framework, you can think of it as these three components. So you have the Flower app. This is the application that you create for whether it is medical or healthcare. You create something that does diabetes prediction or cancer image recognition. For finance, that would be credit score analysis or fraud detection or something. This is the app. This is what you develop in a normal Python script or anything like that. Then you have the superlink. So in deployment, you have Flower Superlink, and this is a long-running process that is hosted on the aggregator side where all the model updates come together. So this one pushes and pulls messages back and forth to the different, let's say, silos, such as the hospitals, or if you are connected to devices, these are what we normally refer to as clients. So you have, in a traditional federated setting, you have the aggregator, and this is where the superlink lives, basically. And that one communicates with the supernode. And the supernode is, they are also long-running processes and are hosted on each single participating client. So if the clients are devices or organizations, one, let's say, hospital would have one supernode. And that one is connected with a superlink that might be connected with another hospital that has its own supernode. And what's good with that is that the superlink and the supernodes are separate from the Flower applications. So they are basically just communicating the messages back and forth. And this allows anyone to submit several applications at the same time because it reduces dependency management because they send the right and the correct messages back and forth. So you could submit several applications such as credit score analysis, fraud detection, anti-money laundering. These are just some use cases that you could work with, but you could submit them in parallel and run them, and the infrastructure would be the same, but you would get the respective results for each application, basically. And we try to make it as agnostic as possible, so you can connect with different software stacks such as PyTorch, TensorFlow, whatever it is. And also you can run it on various devices. This is very important to us. This is just a more in-depth view of how one works with this. So I talked about the superlink and the supernodes, and this is in a hospital example. So you see the superlink is in a kind of trusted, it is a trusted connection between the supernodes and the superlink, and they are pushing and pulling messages back and forth, waiting for an application to be run. A researcher comes in with a sort of server application. This is the Python scripts that run close to the superlink, and then client application. This is the way you do the training or the evaluation on the hospital side of things. So this person comes in with these, let's take Python scripts. They do Flower run plus the application name, in this case, maybe cancer imaging. They send that through in sort of a bundle. First, it comes to the superlink, and then it distributes. So the server app stays close to the superlink, still isolated from each other, but then it sends out copies of the client applications to the different supernodes that are connected to the superlink. And they do some training on site, send the messages back to the superlink. that you do some aggregation, you get a better model, and you continue. So this is the flow. Now, you might have another researcher coming in as well, maybe doing diabetes prediction, something like that. They can submit their own server application and client application through to the superlink. The server application ends up by the superlink, the other one on the supernodes, and there you have several applications running in parallel, but similar sort of infrastructure. And this is how you deploy Flower across these sort of nodes. We have documentation on how to do all of this. So you can go to Flower and check out how to use Docker. We have very extensive sort of documentation on this, on how you can use it. There's a lot of effort going into making this available for everyone out there. So if you're interested in taking, let's say, a simulated run or an experiment and putting it in a global federation or regional federation, you can do that. You can spin up nodes yourself, you can run Flower, and maybe showcase what your federation looks like and your application. I think this is actually it for the deployment. If there are any questions on this, feel free to ask them now.
How scalable is your infrastructure? For example, we have several federal projects going on where we need to have multiple servers are talking to each other. That is running, in a federated manner. For example, we have at UND, we have Iowa State and some Oregon National Lab. We have some DOE project that we have these data sets running. So what kind of support that you can provide, even though it's open source tools? I'm just curious about these new developer options that you mentioned about RAG and other tools. Do you also host or customize working on a particular project with the institution?
Yes, we do. So we recently launched something that we call the Supergrid, which is kind of the Flower platform for larger scale enterprises and things like that. If you need help with maintaining, orchestrating, and updating the system, we can do this. So how we like to see it, or how we imagine it, is, let's say Flower framework, the open source framework, is like Git. Anyone can use it and you can spin up your own servers. But then the Flower Supergrid is like GitHub. So this is where, a nice UI comes into place. It's easy to do certain things because you have features available to you. And this is what the Flower Supergrid would be. So I would just want to put up, like, anyone can work with Flower. We also do support through our Slack channels and on GitHub, our GitHub repository ourselves. But if you need, let's say, us to host the aggregator or help you with orchestrating a full-fledged system, designing how to give how to give access to authorized users and things like that. I think Dimitris will touch upon it as well, but then maybe Flower Supergrid is something that would suit you as well. And to maybe for your first question, how scalable this is, we have done several experiments where it scales, beyond millions of clients as well. So there's the upper limit is quite high, I would say.
Thank you. Just for FYI, we have collections of 25 NVIDIA devices in our campus as part of the DOE project, and not only NVIDIA's AGX Nanos and Raspberry Pis, so we have orchestrated the CI/CD pipeline with AWS. We have AWS as being a partner here. So we are deploying our own architecture for ADS and IDS. We are looking at evaluating Flower, OpenFL, and also a bunch of other tools that's to see how, in what ways, which one is effective in use cases for our project. Also, we want to make sure the infrastructure is also. We want to work with you as well to understand, because maybe you have better resources and maybe we can able to talk after the workshop, or maybe.
Yes, sure. That sounds good. Just as a FYI, so OpenFL is is an initiative run by Intel, but they are archiving that project, and their principal engineer just joined our team. That's Patrick Foley. He is very well invested in what OpenFL has worked with, but the idea is to archive that project by the end of this year or early next year. And all that knowledge is being transferred into Flower as we speak right now. So this is there's an active effort from our side to making Flower compatible with both. You were talking about the NVIDIA GPUs and devices. We are compatible with them. We also try to work with AMD and closely with Intel and any other hardware provider, just so that if you were to run it in larger scale federations and all of a sudden a client comes in and wants to participate with their devices, they might not run with, let's say, NVIDIA devices, then you want to make sure that it is compatible and still kind of sort of a trusted environment for this. So this is something that we are actively working on.
Thank you. Well, I think that's great to know that. I think, I think there's more to learn from you guys and maybe work with you guys even at the proposal stage as we build on other proposals. Thank you.
Right. Yeah. No, we're happy to chat more about it afterwards, but we can follow up then as well. Yeah. Are there any other questions? If not, then we could do a short break here, if that's fine, like a 5 minutes, so you don't have to. Then Dimitris will come in with a demo.
Sure, we can take a 5-minute break.
Okay, sounds good. Yeah, and in the meantime, if there's any other questions, you have our Slack, and you can chat with us there afterwards as well. So maybe, what time is it? Maybe 20 past, is that fine?
Sounds good.
Perfect.
Yes, thank you.
And I think we can also share our emails. Hamza, feel free to share William's email and mine, in case we need to have a follow-up.
Okay, I don't see any questions. I think we can proceed. Guys, thank you.
All right. Thank you, William, for all the great things you shared earlier regarding Flower and the framework aside. So moving forward in this session, what I will try to get is dive a little bit deeper on the internal mechanics of Flower. And just to give a little bit more background, I'll start with how does federated training typically works. So for people or the audience who are not familiar with, so to give a bit background, what federated training does is basically there are 5 critical steps. First step is basically to initialize the global model. And these can be, and then once this is initialized and shared with every other hospital, for instance, or every other client in a network of this federation network, then there is a repetition happening for a couple of rounds. And step 2, the model is sent back to every other client in the federation. In step 3, the clients for instance, here on the right-hand side, you can see the hospitals are doing the model training. And then once training is done after a couple of epochs, then the updated local model is being sent back to the server. And the server at the very end aggregates the updates into to compute the new global model. So this is repeated for a couple of rounds. This is the classical federated training approach, and it's also called as a synchronous federated training. Why I'm referring to this is because I want to give a little bit of context on why different algorithms exist in the Flower framework as examples, as baselines, and how this can be adjusted for different domains, for instance, in the cybersecurity domain. And just to give a little bit of more background, also, Flower baselines is what we actually, is what the community codes and commits to the Flower framework, and is typically coming from different papers, research in the literature. And we are very happy and very keen on actually onboarding many new efforts along this path. So if there is an algorithm that you have recently developed in any domain, feel free to reach out and actually contribute that algorithm to the framework. One example that I will show here is actually given also the focus of the current workshop is statistical average. Why is this? Is because it's an algorithm developed to mitigate data heterogeneity in intrusion detection systems. The core idea is that intrusions in this particular experimental setting are considered as anomalies. So there is a classification task between attacker and anomaly detection. And the core principle behind this research work was to perform a normalization of features before model training is performed. This is just to show that there are different baselines, and that's a indicative example. And feel free to try it out actually by navigating to the GitHub repository and under the baselines path. Also, what I would like also to discuss here is a little bit of other aspects or other tools or even algorithms that can be supported Flower framework. Here, for instance, if you want to perform secure and private thread learning, there is built-in mechanisms currently supported Flower. One is also, as William mentioned already, is differential privacy, which I'll also dive a little bit deeper in the next slide. And there is also secure aggregation, homomorphic encryption, like full homomorphic encryption. And for secure aggregation, there's a secure aggregation plus algorithm also built in the framework. Maybe I'll just give a little bit of context on what differential privacy is. Differential privacy basically assume you have 2 databases and there's an analysis that you want to perform on top of an existing database. The idea is that you actually add some additive noise on top of the records in order to basically perturbate and not reveal directly the original records when the analysis is performed on top of every other database. If you want to learn more and see how all the different security privacy mechanisms are implemented in Flower, please, again, you can navigate under the GitHub repository. I'm not going to dive into it right now, but under the examples path, you can find many of those. And feel free to open a question if you have any in our public community Slack channel. Some examples of differential privacy that are useful to also know about in Flower is central differential privacy and local differential privacy. There's a distinction between those two, and the distinction lies on where the differential privacy mechanism is applied during the federated training approach. Specifically in the central TP, you can see that the aggregator, after receiving actually the model updates from every other client, is applying the DP mechanism on the global aggregated model. And this is basically what can be shared and with external parties in order to, and in a way, secure, avoid information leakage to other external parties. An alternative approach is when you apply local differential privacy, and this is applied at every other client, not at the central server. And in a sense, this can be either before start training, during training, or even after the training is done. So you can think of it as a local DP is a more general context, but the one that is applied right away on the client side, not on the server side. Of course, again, I'll actually point to our documentation. There's actually a very nice explanation of how the different differential privacy concepts are implemented in Flower and what are the distinct features between those two. Now, changing a bit of gears, what I want to discuss now is a little bit of how the latest releases of Flower are working under the hood. And this is basically using the message API. Compared to the versions of Flower like 1.0, the latest versions are using message API instead of the server-based strategies approach. This, just to give a low-level approach or description of what the message API does, you can think of, you see here that I have a server app and a client app. When I register each other application, you can see that I have on the server side, there's a main function, there's a decorator for the main function that actually has access to the grid and the context. Similar on the client app, I have the application and I have a decorator that's called train. So the idea is that the server app, once there is a federal learning job that needs to be executed in the federation, there's going to be triggered and submitted to the client app through the train function. And all this interaction between server app and client app is done through message API, the message API. And the messages that are being exchanged throughout the execution of the federation contain parameters, metrics, configs, anything that you can imagine. So it's basically easy to use, and you can add your own extensions. For instance, also, you can have your own customized messages. For instance, you can actually have your own custom function that you want to call. For instance, here, we don't going to perform a train or evaluate, but we're going to just run a query function. And this query is going to basically call the echo function that is defined the client. And the reply is basically, again, a custom message. So it doesn't have to comply in a specific format. It can be any type of message that you can think of, and this is going to be received by the server in order to proceed, maybe follow up with another federal learning job or perform some type of aggregation. So this is the flexibility of the low-level message API, and we did this redesign in order to give full control on the execution flow. Basically design whatever architecture you like, whatever message you want to pass, so you don't really have to stick with a strategy API. This doesn't mean that the strategy API is not compatible anymore. It's still compatible. There's backward compatibility, but message API is actually the way to go. Is there a question? Can make a Q&A. I saw something on the chat, but okay.
There is. Should I let
Oh
you
yeah.
know?
So there's a question about stat average again on how it's related to IDS. Yes. So basically, the idea that this is a contribution from the community, and in this research paper, basically just to give you a perspective, the idea is that they have different intrusions that happen on the data. And so they're trying to find some anomaly detection, so detect anomaly